All right, let's take a look at an example where we actually apply this idea of systems of equations. So let's say your family starts a bed and breakfast. But before you get your business started, it costs $500 to fix up a bedroom before you start renting it out. And then once you get up and running, the cost for food and utilities, electricity, water, is $10 per night. And who you rent to, though, your family charges $60 per night to rent the bedroom. So we're looking at how many nights does your family need to rent out the bedroom before breaking even? Because obviously it costs something to get the business started before you actually start making a profit off the $60 per night. So in fact, let's write two equations that goes with this. Let's write an equation for cost. So if you think about what the cost would be, it says right here, let me underline these important parts here, that the cost to fix things up before renting, and then another $10 per night for food and utilities. So we would come up with an equation like this. Let's say y represents the total amount of money, or the total cost. Well, y would be equal to $500 to fix up the bedroom, just that one time, and then $10 per night, where the number of nights, we'll call that x. All right, so y is the total amount of money, and x is going to represent the number of nights. All right, so there's our one equation. But then we're going to have a second equation here because we also have to account for the money coming in. So we call that revenue. All right, so if we use the same variables, though, where x is the number of nights and y is the total amount of money, we have one piece of information about that, is that your family is charging $60 per night. So the total amount of revenue, y, that's going to come in is going to be $60 for X number of nights that you rented out. All right, so here's our system of equations, and we're going to do a comparison of the two to see how many nights it takes before breaking even. All right, so let's transfer this information to another page. All right, so in your notes, go ahead and put this graph in. Okay, and since negative numbers don't make sense, we're just going to graph positive numbers. So for the nights, I've already figured this problem out ahead of time. Why don't you go ahead and put the graph going by ones. But then for the amount of money, why don't you go by hundreds. And then while you're doing that, we'll put this over here. Oops, come on. All right, so the idea is that we can solve for this break-even point by actually graphing this. All right, so for the cost, I'll graph this one in red so it matches. It's in slope-intercept form. Y is by itself. So this is why we did all that work in chapter 4. So the y-intercept, the number off by itself, is the 500. So that graph is going to start here at 500. This is how much it costs your family up front to fix up the bedroom, and then $10 per night. All right, so if each of these blocks is 100, you'd go up 10 over one night. Up 10 over one night. Now here's a little trick. Here's what I'm going to do. I'm doing the slope 10 over 1, which I'll put right here. But with the increments that I've got on my graph, what I'm going to do is I'm going to actually multiply the top and bottom of this fraction by 10. So I'm actually doing the opposite of simplifying my fraction. So it would be 100 over 10 is the same thing as 10 over 1. I just multiply top and bottom by 10 because that's easier for this graph. So now I can rise 100 and run 10. And it lines up with the graph paper a little better. I can pull a line out and I can graph it. Okay, so this line represents all the costs that your family incurs. All right, now though, the idea of a system of equations like we've been learning about is to just overlay the other information and compare the two. So we're going to now graph this one. Now this one, our revenue, is also in slope-intercept form. Y is by itself. Y equals 60x, and then in this case, the easy way to do this is plus 0, because we need a number over here to represent the y-intercept. So our y-intercept is 0, and the slope would be up 60 over one night. Up 60 over one night. Again, though, that's a little hard to do on this graph, so again, I'm going to do that same trick. The slope is 60 over 1, and to match the increments of this graph, I think it'd be better if I multiply top and bottom of this fraction by 10. So the equivalent slope would be 600 over 10. So if I go up 600 and over 10 nights, I'm going to get another dot right there. And so my line will go from the y-intercept through like that. All right, so basically the way I read this graph and what's going on here is that if this is the costs, oops, I should do that in red. Oop, too far. So if this line represents the costs and this line represents the revenue, what this graph is telling me is that for a while we're operating this business and we're not making any money, right? Because the cost to run the bed and breakfast is more than what's the money I'm taking in, up until right here where the two lines cross. This is the intersection of the two lines, which is sometimes called the solution to the system, but in this case this is also called the break-even point. This is where we're breaking even. And so to answer the original question over here, how many nights does your family need to rent out before breaking even? It would be 10 nights. Okay, and once we hit that 10-night mark and our business is successful, notice over here on the graph, the revenue line is going to be above the cost line, so now we're finally making money. Okay, whatever the difference is between these two lines, that's how I'm making each night. All right, but I think a key piece here is understanding that this crossover point is what we call the solution to the system, or in this case, the break-even point, which is 10 nights. All right, so this is how we use system of equations to solve real-world problems.